Part 5 Contexts and Dependency Injection for the Java EA Platform. Part V explores Contexts and Dependency Injection for the Java EA Platform. This part contains the following chapters. Chapter 28, Introduction to Contexts and Dependency Injection for the Java EA Platform. Chapter 29, Running the Basic Contexts and Dependency Injection Examples. Chapter 30, Contexts and Dependency Injection for the Java EA Platform. Advanced Topics. Chapter 31, Running the Advanced Contexts and Dependency Injection Examples. Introduction to Contexts and Dependency Injection for the Java EA Platform. Contexts and Dependency Injection 401 for the Java EA Platform is one of several Java EA 6 features that help to knit together the web tier and the transactional tier of the Java EA Platform. 401 is a set of services that, used together, make it easy for developers to use Enterprise Beans along with JavaServer Faces technology in web applications. Designed for use with stateful objects, 401 also has many broader uses, allowing developers a great deal of flexibility to integrate various kinds of components in a loosely coupled but type-safe way. 401 is specified by JSR 299, formerly known as JavaBeans. Related specifications that 401 uses include the following. JSR 330, Dependency Injection for Java. The Managed Beans specification, which is an offshoot of the Java EA 6 platform specification. JSR 316. The following topics are addressed here. Overview of 401 about Beans. About Managed Beans. Beans as injectable objects using qualifiers. Injecting Beans using scopes. Giving Beans EL names. Adding setter and getter methods using a Managed Bean in a facelets page. Injecting objects by using producer methods. Configuring a 401 application. Further information about 401. Overview of 401. The most fundamental services provided by 401 are as follows. Contexts. The ability to bind the lifecycle and interactions of stateful components to well-defined but extensible lifecycle. Context dependency injection. The ability to inject components into an application in a type-safe way, including the ability to choose at deployment time which implementation of a particular interface to inject. In addition, 401 provides the following services. Integration with the expression language EL, which allows any component to be used directly within a JavaServer Faces page or a JavaServer Pages page. The ability to decorate injected components. The ability to associate interceptors with components using typesafe interceptor bindings. An event notification model. A web conversation scope in addition to the 3 standard scopes: request, session, and application defined by the Java Servlet specification. A complete service provider interface SPI that allows third-party frameworks to integrate cleanly in the Java EA 6 environment. A major theme of 401 is loose coupling. 401 does the following. Decouples the server and the client by means of well-defined types and qualifiers, so that the server implementation may vary. Decouples the life cycles of collaborating components by doing the following. Making components contextual, with automatic lifecycle management allowing stateful components to interact like services, purely by message passing. Completely decouples message producers from consumers, by means of events. Decouples orthogonal concerns by means of Java EA interceptors along with loose coupling. 401 provides strong typing by eliminating lookup using string-based names for wiring and correlations, so that the compiler will detect typing errors. Allowing the use of declarative Java annotations to specify everything, largely eliminating the need for XML deployment descriptors, and making it easy to provide tools that introspect the code and understand the dependency structure. At development time. About Beans. 401 redefines the concept of a bean beyond its use in other Java technologies, such as the JavaBeans and Enterprise JavaBeans EJB technologies. In 401, a bean is a source of contextual objects that define application state and or logic. A Java EA component is a bean if the lifecycle of its instances may be managed by the container according to the lifecycle context model defined in the 401 specification. More specifically, a bean has the following attributes: a non-empty set of bean types, a non-empty set of qualifiers C using qualifiers, a scope C using scopes optionally, a bean EL name C giving beans EL names, a set of interceptor bindings, a bean implementation. A bean type defines a client visible type of the bean. Almost any Java type may be a bean type of a bean. A bean type may be an interface, a concrete class, or an abstract class and may be declared final or have final methods. A bean type may be a parameterized type with type parameters and typed variables. A bean type may be an array type. Two array types are considered identical only if the element type is identical. A bean type may be a primitive type. Primitive types are considered to be identical to their corresponding wrapper types in Java. A bean type may be a raw type. About managed beans. A managed bean is implemented by a Java class, which is called its bean class. A top-level Java class is a managed bean if it is defined to be a managed bean by any other Java EA technology specification, such as the JavaServer Faces technology specification, or if it meets all the following conditions. It is not a non-static inner class. It is a concrete class or is annotated. Decorator. It is not annotated with an EJB component defining annotation or declared as an EJB bean class in EJB jar. XML. It has an appropriate constructor. That is, one of the following is the case. The class has a constructor with no parameters. The class declares a constructor annotated. Inject. No special declaration, such as an annotation, is required to define a managed bean. Beans as injectable objects. The concept of injection has been part of Java technology for some time. Since the Java EA5 platform was introduced, annotations have made it possible to inject resources and some other kinds of objects into container-managed objects. 401 makes it possible to inject more kinds of objects and to inject them into objects that are not container-managed. The following kinds of objects can be injected. Almost any Java class session beans Java EA resources. Data sources, Java message service topics, queues, connection factories, and the like. Persistence contexts JPA EntityManager objects producer fields objects returned by producer methods web service references remote enterprise bean references. For example, suppose that you create a simple Java class with a method that returns a string. Package greetings. Public class greeting public string greet string name return hello plus name plus semicolon. This class becomes a bean that you can then inject into another class. This bean is not exposed to the EL in this form. Giving beans EL names explains how you can make a bean accessible to the EL. Using qualifiers. You can use qualifiers to provide various implementations of a particular bean type. A qualifier is an annotation that you apply to a bean. A qualifier type is a Java annotation defined as target method, field, parameter, type end. Retention runtime. For example, you could declare an informal qualifier type and apply it to another class that extends the greeting class. To declare this qualifier type, you would use the following code: package greetings, import static Java, annotation, element type, field, import static Java, annotation, element type, method, import static Java, annotation, element type, parameter, import static Java, annotation, element type, import static Java, annotation, retention policy, runtime, import Java, annotation, retention, import Java, annotation, target, import javax, inject, qualifier, retention runtime, target type, method, field, parameter public, interface informal. You can then define a bean class that extends the greeting class and uses this qualifier. Package greetings. Informal public class informal greeting extends greeting public string greet string name return hi plus name plus exclamation mark. Both implementations of the bean can now be used in the application. If you define a bean with no qualifier, the bean automatically has the qualifier. Default. The unannotated greeting class could be declared as follows. Package greetings. Import javax. Enterprise. Inject. Default public class greeting public string greet string name return hello plus name plus semicolon. Injecting beans. In order to use the beans you create, you inject them into yet another bean that can then be used by an application, such as a JavaServer Faces application. For example, you might create a bean called printer into which you would inject one of the greeting beans. Import javax. Inject. Public class printer. Inject greeting. This code injects the default greeting implementation into the bean. The following code injects the informal implementation. Import javax. Inject. Public class printer. Inject. Informal greeting. More is needed for the complete picture of this bean. Its use of scope needs to be understood. In addition, for a JavaServer Faces application, the bean needs to be accessible through the AL. Using scopes. For a web application to use a bean that injects another bean class, the bean needs to be able to hold state over the duration of the user's interaction with the application. The way to define this state is to give the bean a scope. You can give an object any of the scopes described in Table 28-1, depending on how you are using it. Table 28-1 Scope Annotation Duration Request. Request scope the user's interaction with a web application in a single HTTP request. Session scope the user's interaction with a web application across multiple HTTP requests. Application scope shared state across all users' interactions with a web application. Dependent. The default scope of none is specified. It means that an object exists to serve exactly one client bean and has the same lifecycle as that client bean. Conversation scope the user's interaction with the JavaServer Faces application, with an explicit developer-controlled boundaries that extend the scope across multiple invocations of the JavaServer Faces lifecycle. All long-running conversations are scoped to a particular HTTP servlet session and may not cross session boundaries. The first three scopes are defined by both JSR 299 and the JavaServer Faces API. The last two are defined by JSR 299. You can also define and implement custom scopes, but that is an advanced topic. Custom scopes are likely to be used by those who implement and extend the 401 specification. A scope gives an object a well-defined lifecycle context. A scope object can be automatically created when it is needed and automatically destroyed when the context in which it was created ends. Moreover, its state is automatically shared by any clients that execute on the same context. Java EA components, such as servlets and enterprise beans, and JavaBeans components do not by definition have a well-defined scope. These components are one of the following. Singletons, such as Enterprise JavaBeans singleton beans, whose state is shared among all clients. Stateless objects, such as servlets and stateless session beans, which do not contain client-visible state objects that must be explicitly created and destroyed by their client, such as JavaBeans components and stateful session beans, whose state is shared by explicit reference passing between clients. If, however, you create a Java EA component that is a managed bean, it becomes a scope object, which exists in a well-defined lifecycle context. The web application for the printer bean will use a simple request and response mechanism, so the managed bean can be annotated as follows. Import javax. Inject. Import javax. Enterprise. Context. Request scope public class printer. Inject. Informal greeting. Beans that use session, application, or conversation scope must be serializable, but beans that use request scope do not have to be serializable, giving beans EL names. To make a bean accessible through the EL, use the name built-in qualifier. Import javax. Inject. Import javax. Enterprise. Context. Request scoped. Import javax. Inject. Named. Request scope public class printer. Inject. Informal greeting. The named qualifier allows you to access the bean by using the bean name with the first letter in lowercase. For example, a facelets page would refer to the bean as printer. You can specify an argument to the named qualifier to use a non-default name, named myPrinter. With this annotation, the facelets page would refer to the bean as myPrinter, adding setter and getter methods. To make the state of the managed bean accessible, you need to add setter and getter methods for that state. The createSalutation method calls the bean's greet method, and the getSalutation method retrieves the result. Once the setter and getter methods have been added, the bean is complete. The final code looks like this. Package greetings. Import javax. Inject. Import javax. Enterprise. Context. Request scoped. Import javax. Inject. Named. Request scope public class printer. Inject. Informal greeting. Private string name. Private string salutation. Public void create salutation this. Salutation equal greeting. Greet name. Public string get salutation return salutation. Public string set name string name this. Name equal name. Public string get name return name. Using a managed bean in a facelets page. To use the managed bean in a facelets page, you typically create a form that uses user interface elements to call its methods and display their results. This example provides a button that asks the user to type a name, retrieves the salutation, and then displays the text in a paragraph below the button. Form id equal greet. Output label value equal enter your name. For equal name. Input text id equal name value equal printer. Name. Command button value equal say hello action equal printer. Create salutation. Output text value equal printer. Salutation. Form. Injecting objects by using producer methods. Producer methods provide a way to inject objects that are not beans, objects whose values may vary at runtime, and objects that require custom initialization. For example, if you want to initialize a numeric value defined by a qualifier named maxNumber, you can define the value in a managed bean and then define a producer method, getMaxNumber, for it. Private int maxNumber equal 100. Produces maxNumber and getMaxNumber return maxNumber. When you inject the object in another managed bean, the container automatically invokes the producer method, initializing the value to 100. Inject maxNumber private int maxNumber. If the value can vary at runtime, the process is slightly different. For example, the following code defines a producer method that generates a random number defined by a qualifier called random. Private Java. Util. Random equal new Java. Util. Random system. Current time millis. Java. Util. Random get random return random. Produces random and next return get random. Next int maxNumber. When you inject this object in another managed bean, you declare a contextual instance of the object. Inject random instance. Integer. Random int. You then call the get method of the instance, this number equal random int. Get. Configuring a 401 application. An application that uses 401 must have a file named beans. XML. The file can be completely empty. It has content only in certain limited situations, but it must be present. For a web application, the beans XML file can be in either the webinf directory or the webinf classes beta-inf directory. For EJB modules or jar files, the beans XML file must be in the meta-inf directory. Further information about 401 For more information about 401 for the Java EA platform, see Contexts and Dependency Injection for the Java EA platform specification, HTTP, JCP, org, N, JSR, detail, id equal 299 an introduction to Contexts and Dependency Injection for the Java EA platform, HTTP, docs, JBOSS, org, weld, reference, latest, and US, HTML, dependency injection for Java specification, HTTP, JCP, org, N, JSR, detail, id equal 330.